I'm Boris Parák from CESNet, and I work with EGI federated cloud, and I will demonstrate interoperability between different cloud management frameworks using rOCCI as the underlying technology. As you can see on the screen, we have three different cloud management frameworks. That's OpenNebula, OpenStack, and Cinefo. And we are using rOCCI client, one of the rOCCI implementations, client implementations. So right now I will show you how I can contact three different sites using three different cloud management frameworks. And in each site I will launch a virtual machine. I will first explore the site and then launch a virtual machine using rOCCI. This is all scripted, but you can also see the commands the script is executing. So there is nothing hidden inside the script. It's just the mechanism. So as we can see, we are using rOCCI client, and I'm starting right now. I have to request credentials because we are using EGI federated cloud, and we are using BONS as the authentication method. So if I get it right, exactly. So right now I have credentials, and I'm accessing the first site. It's actually our site at CESNet, and it's running OpenNebula and rOCCI server. As you can see, I listed all available compute instances, and nothing is running. So I have no machines instantiated at the moment. Let's move forward, and we will list OS templates. OS templates are mixins. That's an rOCCI terminology used to identify types of operating systems. So you can see a lot of operating system images or appliances. We will next list resource templates. Resource templates are used to identify the size of the instance you are going to launch. We can see some small, large, medium, and so forth. Each template carries an information about the size of the instance, the number of CPU cores, and the amount of memory. So let's try to instantiate the virtual machine. As you can see, I'm doing a resource compute action create call, and it's not very visible, but this part has just been returned by the client, and it means an instance has been instantiated, and this is its handle. So I can use this to query the instance, which is what I'm doing right now. I will first check that you can actually see the instance in the list. Before it was empty, and now we see there is one instance running, the one I just launched. Now I will use the describe action to actually find out more about the instance I just instantiated. So here you see a rather complicated output, but the important part is rOCCI compute state. It's inactive, it means the machine is still launching in the background. And then between links, or in links, you can see network interface address. This is the address you can use to connect to the virtual machine once its state is active. Let's move on. I will delete the instance because we don't have time to wait for an instance to spin up. Instance has been deleted, and now we can proceed to another EGI Fed cloud site, and I will demonstrate the same behavior under different or communicating with a different cloud management framework. We are trying IFCA, which is a site in Spain, and uses OpenStack. So it has a different rOCCI implementation called rOCCI OS. And as you can see, we can list instances, and IFCA has some running. And I will repeat the whole process. So I will list OS template, mixins, as you can see. As you can see on the screen, I successfully listed resource template mixins. And we can move forward and instantiate a virtual machine. The command is exactly the same. I'm just using those mixins I listed just before. So mixin M1 small and mixin I won't read that, it's an identifier. But that's the process in rOCCI. You have to query the site. You have to dynamically find out what the site can offer you, and then you can use it. So as you can see, the instance has been created. We have an identifier. Again, I will list compute instances, and we will see one additional compute instance I just created. The time for these actions to return is dependent mostly on the network here, since I'm using Wi-Fi, and also on the load of the cloud management framework, because it doesn't have high priority to respond to these requests. So if their OpenStack instance is under heavy utilization, it will take some time to respond. Okay, so instance is included in the list of compute instances. Now I can describe the instance. So again, you will see some visualization of what rOCCI is sending me over the wire. Again, compute state is unfortunately still inactive because we don't have the time to wait for it to spin up. But again, you can see a network address. At this time, it's private, but you can also attach addresses via rOCCI, so you can request a public address, which I'm not demonstrating right now, but it also works.
So how long does it normally take to spin up?
It's really dependent on the state of our infrastructure and on the size of your machine. Recently we had some problems with the Atlas VO because they are using CERN VM.
Yeah.
And in some sites it has to be expanded to its full size. So you can use, in sites you are running KVM, you can use the very small image, which then can expand once you fill it with data.
Right.
Our site is running Xen, and we don't support QCOW.
Right.
So we have to expand that image to RAW, and we are basically launching virtual machines with 40 or 50 gigabytes of drive from the beginning. And we have to deploy it to our local cluster, and if you spin 10 or 20 of these machines at the same time, it goes up to a terabyte we have to transfer through the network. So it takes time to instantiate. We are working on optimizations, and we will actually be switching to KVM in a few weeks, hopefully. Mm-hmm. So we will improve the time we redesigned our infrastructure to give it more power when it comes to deployments. But unfortunately, it's very dependent on the actual site you are deploying and on the virtual machine you are deploying.
Okay, because I know there was some people at INRIA in Contrail who did research on minimizing the image before deployment, and at RAL we had CVMFS-based deployment, which meant that a machine would be ready to run in 6 seconds.
Yeah, exactly. It's definitely doable, but it very much depends on what your user base is. Because if you have a fairly uniform user base, you can optimize to their needs.
Yes.
Our local cloud is for anybody. So we don't know what is inside the virtual machine.
Who may come with their own virtual machine.
Yeah, exactly. They are coming from with their own virtual machine images. So it's really difficult to optimize. We had some Windows images which were almost 100 gigabytes.
Yeah.
And there is no way to optimize that and still operate the cloud with as little personnel as we have. So
yeah, absolutely.
But it's definitely doable, and there are ways to optimize it. If you have the right hypervisor, there are tools to zero out parts of the file system so you can more effectively compress it. There are methods to copy it through the network in a more intelligent way, so you don't have to actually copy each. If you are deploying multiple instances of the same machine, you don't have to copy the same image for the same machine. You can use Wave, or I'm not sure how it's called, but Wave SCP, when you can actually copy one instance of the image to a physical host, and then that physical host will copy it to 2 additional physical hosts, and each of those 2 physical hosts will copy it into other physical hosts. So you are distributing the load and similar techniques. So there are definitely ways to optimize it.
Okay.
Okay, so I removed the instance, and we can move on to another EGI Fed Cloud site. And the last site I will demonstrate is actually running Cinefo. That's a Greek platform. They have a quite large cloud called Okeanos. It's their national cloud. And again, I am listing existing compute instances, and I will go through the whole process again. I think there is no need to explain it again. So if you have any questions, additional questions, now is the time to ask, since this will be running quite a while, because they have a lot of OS templates and a lot of research templates, so it takes a while on slow connection. No questions? Okay, so I can continue describing what's happening on the screen. Also, as you can see, we are using quite verbose identifiers to launch virtual machines, these mixins. rOCCI client, which is running underneath this script, is actually constructed in such a way that you can use only a unique part of the mixin. So we have what I would call a guessing framework, which can guess what you need, and will try to identify the right mixin. So you don't have to remember the whole schema. You simply have to remember something that will identify the type of the mixin, OS template or resource template, and then what we call CCI term, and that's the part after the hashtag. So I can actually launch a virtual machine using just resource template hashtag the term and OS template hashtag the term. I don't have to write the whole OCCI schema, because if you want ordinary users to use it from shell, this is unusable. They wouldn't be able to remember or even copy-paste successfully some of these identifiers. So that's why we support those guessing mechanisms, which of course are not applicable always, because if there is something similar and they cannot decide which one to pick, they will of course end up with an error and you have to use the full identifier. But in most cases, you just, as you can see here, I am writing resource compute. I'm not writing the full HTTP, schemas, OGF, org, OCCI infrastructure compute identifier. I am just writing compute. And the client underneath will look into the model provided by the server and will do a dynamic lookup. And I will translate this one word into the full identifier. And then again look into the model, and according to the identifier, I can find the location. So I actually know where should I send the request to the server, which is usually a URL or...
Are you planning to have a browser interface for even less skilled users?
In EGI Federated Cloud, we have what we call high-level platforms. So we have brokers and frameworks and I know what the right name for workflow orchestration tools, or Daniele just arrived and he has comps Superscaler, for example. That's one of those tools we use to orchestrate workflows for users who actually don't want to use OCCI. This is mostly used behind the scenes. So you don't, if you use Dirac, or you use Catania Science Gateway, or you can use comps, or you can use anything using JSaga adapters. All these contain a rOCCI client inside wrapped, and they can actually abstract all this for the user. So you are simply clicking in GUI and machines are popping up. And okay, so we have a compute instance. I can describe that compute instance again. You can go through all this on all our sites, no matter which platform they are running. It looks the same, and hopefully. And we're here, okay. So again, you can see, oh, they actually managed to spin up the instance. So I have state active. I have an IP address which I could connect to right now if I wanted to. And then some information which I didn't explain in the previous examples. Here are the mixins we used to launch the virtual machine. And here are some actions, because we support triggering actions. So I can actually use rOCCI client to stop the machine, suspend the machine, resume the machine. This is all you can do. Again, on multiple sites, we are trying to abstract from differences between platforms. So, for example, in rOCCI server, one of the server implementations, we have code that will try to emulate behavior. So, if, for example, in OpenNebula, you have to if you want to resize a machine, you have to stop the machine first, then you can resize it, and then you have to explicitly start it again. In OpenStack, you can resize it directly. So what we do is the server-side code will handle the stopping, the resizing, and the starting again for you. So you don't know that you have to do that. You simply issue one command, and we will take care of this difference, and we will stop the machine, resize it, and then start it again, and then return to your call. So you don't have to know that this platform is handling this differently. And there are of course differences between OpenNebula and Amazon Web Services, EC2. there will be differences between Amazon and Microsoft Azure, which we are working on right now. So with each new platform, we are adding new abstractions and new mechanisms to actually handle this, so that the user doesn't have to know and doesn't have to handle it. Okay, right now I am deleting the instance, and once the instance is deleted, this is the end of the demo. Let's wait for that. Okay, and it's deleted, and that was the last site. We have about 20 sites at the moment, which are what we call certified, which are monitored by Nagios and have certain rules they have to adhere to regarding availability and reliability. So these were just 3 of them, but I picked these 3 to represent those 3 different cloud management frameworks we are using. So thank you for your attention. If you have any questions, please
Thank you.
ask.